In this example, we're going to look at long division of polynomials to divide this polynomial by 3x minus 2. Previously, we've looked at synthetic division, which is kind of a shortcut algorithm to divide by linear factors of the form x minus a. This doesn't take that form because it has something in front of the x. It could also, this process of long division could also be used to divide by things that aren't linear, such as if we had a quadratic factor over here, or a cubic, or even anything higher than that. So let's take a look at how to set it up. You will have the 3x to the fourth minus 5x cubed plus 2x squared plus 3x minus 2 underneath our division symbol. Think back to like elementary school division. We write our division this way, and we will have our 3x minus 2 out in front of this. If you remember back to elementary school doing long division of numbers, this is a very similar process. There's just some variables involved with this as well. So first we're going to figure out what to put up here so that when we multiply it by 3x, we will get 3x to the fourth. And that would just be x to the third. Once I figure that out, I'm going to distribute it down to both of these pieces and put those answers under the next two pieces here. So x to the third times 3x makes 3x to the fourth. X to the third times negative 2 makes negative 2x cubed. And then again, trying to think back to this long division algorithm for numbers, once you do this, then you subtract. This is a little different than the synthetic division where we were adding things at this point, so you've got to be careful and make sure that you remember that we're subtracting here. So subtract here, 3x to the fourth minus 3x to the fourth, those would cancel out. And here's where students make a sign mistake a lot of times. Negative 5x to the third minus negative 2x to the third, that double negative there, the minus negative, really becomes plus positive. So negative 5x to the third plus 2x to the third should leave you with negative 3x to the third, like that. Drop down your next term and repeat. Figure out what times 3x gives you negative 3x to the third. And that should be negative x squared. Take that negative x squared, distribute it down to both of these, write those answers under here, and subtract. So negative x squared times 3x is negative 3x cubed. Negative x squared times negative 2 is positive 2x squared. Subtract. Anything minus itself cancels out. Again, anything minus itself, this would cancel out and leave you with 0x squared right there. And drop down your next term. What times 3x gives you 0x squared? That would be 0x, or just 0. I'm going to write 0x just to keep with the pattern for this. 0 times that is 0. 0 times that is also 0. And subtract. You get 3x right there. That step was kind of trivial. And then finally bring down your minus 2 and repeat. What times 3x gives you 3x? Well, that would just be 1. 1 times that stuff. Go ahead and distribute that down. 1 times 3x and 1 times negative 2 makes 3x and negative 2. And subtract. I'm running out of room there, but when you subtract that, anything minus itself is 0. So there's your remainder. This number that you're left over at the end with down here would be your remainder. In this case, it's a remainder of 0. And up here, above this, we have our quotient. So if I wanted to go ahead and summarize that, I'll write that in the space down here. The quotient would be x to the third minus x squared. I wouldn't write the plus 0x term in my final answer, and then just plus 1. So here is our quotient. Here is our remainder, depending on what the question asks you to answer. If it wants to know the quotient and the remainder, there's your quotient, there's your remainder for that. So that's how long division works. I'm sure you can find other examples online. If you need to look at some other examples, if that one didn't quite do it for you, feel free to use the resources available to you in 2020 if you need any more help.